absolute value, remember the absolute value of a number and its opposite equal the same thing. So the absolute value of 4 is 4, the absolute value of negative 4 is 4. What that means is that if we have a variable inside of absolute value, there's going to be two possible answers for that variable usually. Now, this is how it looks in practice. Okay. If I have the absolute value of something equals 36, what that means is what's inside of here, the 5x minus 11, could itself equal 36, or what's inside of there, 5x minus 11, could equal negative 36, because if it equals negative 36, the absolute values will make it positive. All right, so to find out my possible x values, I have to solve both of these. Now, same set of steps for each. So add 11, 5x's equals 47, divide by 5, x equals 9.4. Okay, that's one of my possible solutions. My other possible solution is add 11 to both sides. Be careful with this because you're going to be tempted to make a mistake right there. 5x is equal negative 36 plus 11, opposite sides, fight, subtract, negative 25. Divide both sides by 5. And we got x equal to negative 5. All right, both of them are possible answers to this. So if you only give me one of the two possible answers, you only get half credit for an absolute value question. All right, be on the lookout for two answers to absolute value problems. If you've got stuff outside of the absolute value, before you start working with two possible answers, isolate the absolute value as if the whole absolute value is your variable. So before I break this into two problems, I would subtract 5 from both sides. All right, negative 3 times absolute value plus 5 minus 5 cancel out. Minus 5 keeps balance, 18. Then I would divide by negative 3 on both sides, or times 1 over 3. That accomplishes the same thing. 1 over negative 3, my fault. 1 negative third of negative 3 cancels out. Absolute value of n over 2 minus 14 equals negative 6. Okay, now that the absolute value is isolated, now you do what you did before. Break this into two pieces. What would those two pieces be? Actually, let me point this out. I do not need to break this one into two pieces because I know something. Okay, absolute value is going to result in a positive answer. There is no n that I could put in here to make this true. Okay, no n I could put in there to make that true. So the answer here is going to be no solution. All right, we'll look at another one like this where you can get a solution. Actually, matter of fact, the next one, I'm going to say, you try it, hit pause, you try it, then look at my solution. All right, this is the one you're going to try. Subtract 4 from both sides. Break it into two pieces. What's inside that absolute value could equal negative 10 or positive 10. Solve each of those. So add 11 to both sides. Divide by 6. That's the solution. All right, when you have variables inside of absolute value and outside of absolute value, it starts to get really weird. Okay? Still, I want to isolate my absolute value. So 4x is minus 1. Absolute value of that equals, subtract 10 or subtract 7 from both sides. 2x plus 10. All right? Now, what is inside here might be able to equal exactly that. 4x minus 1 equals 2x plus 10. Or it's possible that what's inside here, 4x minus 1 equals the complete opposite of this. So negative 1 times this. And that means I'm going to have to change all signs. Negative 2x minus 10. Okay? We do the math as before. Subtract 2x from both sides. Add 1 to both sides. These will cancel. We'll get 11. These will cancel. We'll get 2x. 2x is 11. Divide both sides by 2. And we'll get x equals 5.5. Or, looking over here, add 2x to both sides. Add 1 to both sides. And we'll have 6 x's. These cancel. These cancel. Negative 9. Divide both sides by 6. And we got x equals negative 1.5. Okay? Here's going to be the thing though. When you've done that, you get your two answers. You need to check each of them with the original problem. Okay, sometimes one of them will not actually work. If they don't work, they're called extraneous solutions. All right, extraneous solutions. So, this is how that works. All right, you take your calculator, which may or may not do absolute values for you. So if it doesn't, this is what you got to do. All right, let's say x is 5.5. 4 times 5.5 minus 1. All right, that's a positive answer. That's a positive 21, so I'm all good. Add my 7 to it. So if x is 5.5, I get 28 on the left side of this equation. Try it over here. 2 times 5.5 plus 17. I get 28 on the right side of the equation. All right, that's all good. This solution is good. Looking at the other side, what if x is negative 1.5? 4 times negative 1.5. 4 times negative 1.5 minus 1 is negative 7. Now I need to flip that because the absolute value will make it positive 7. So positive 7 plus 7 is 14. Check over here. 2 times negative 1.5 plus 17 equals 14 as well. All right, now that's all good. Both of these are solutions. X equals 5.5, X equals negative 1.5. They both work. You got to tell me they both work. All right, I'll show you another one where at least one of them does not work. All right, let's see if we can make this not work out well. Looking for an absolute value with an extraneous solution. So again, what's inside of here should be able to equal 5x minus 9. Or should be able to equal the opposite of that. So negative 5x plus 9. All right, remember you switch all signs when you're creating an opposite. Equal to 2x plus 11. Okay? Solving each of these, let me subtract 2x. Let's get rid of that. Let me add 9. Let's get rid of that. 20 equals 3x. Or let me add 5x. Let's get rid of that. Subtract 11. Get rid of that. Negative 2 equals 2x. My bad. 2x plus 5, 7x. Divide by 3, both sides. X equals 6 2/3. Or divide by 7 on both sides. X equals negative 2/7. Okay, I have my two solutions. Now, I'm going to type each of these solutions into the original equation. So 2 times 6 2/3 . All right, and if you want to put a mixed number in a calculator, you can put it in by saying 6 plus 2 divided by 3. Just make sure you put that in parentheses. So 6 2/3. All right, we got 2 times that plus 11. That gives me a 24.3 repeating. On the left side, 5 times 6 2/3 gives me the same thing. Okay, so this one's cool. That's a true solution. Coming over here, 2 times negative 2/7. That'll be negative 4/7. Negative 4/7 plus 11 will be 10 3/7. On the left, on the right-hand side, we got 5 times negative 2/7. So negative 10/7 minus 9. It's going to be negative 10 3/7. Positive 10 3/7 is not the same as negative 10 3/7. So this is an extraneous solution. Okay, it does not actually solve that. So this absolute value only has one true solution. All right, so you got to be on the lookout for that. If you have x's inside and outside of absolute values, that's when you need to test all of your solutions. Inequalities, same deal, except if you have an absolute value less than something, all right, this can be smaller than or equal to 1. All these things in here, plus all the negatives, right, would make that true. But problem is, this turns everything positive. So if I have something that is like -8 inside of there, it's going to make it a +8. It's going to make it untrue. So the smallest that I can actually make this is -1. All right, the opposite of this. Okay, so I need all of my answers to be between -1 and +1. So what that means is if you have an absolute value coupled with an inequality symbol, it actually turns into a compound inequality, right? 2f plus 3 is smaller than or equal to 1, and 2f plus 3 is bigger than or equal to -1. Okay, that compound inequality. Now, we already looked at solving compound inequalities last lesson, but I'll complete this out here. All right, subtract 3 from both sides. 2f is less than or equal to -2. Divide by 2 on both sides. F is less than or equal to -1. And subtract 3 from both sides. 2f is greater than or equal to -4. Divide by 2 on both sides. F is greater than or equal to -2. All right, so my final solution for the variable, not for the full absolute value, is 0, -1, -2. F can be smaller than or equal to -1, so that's a closed circle. F can be bigger than or equal to -2, so another closed circle, bigger than this, smaller than that. So that little section there is all that F can be. If you got a more complicated situation, isolate your absolute value first. So subtract 8 from both sides. We get absolute value of y plus 5 over -3 is less than -6. Multiply both sides by -3. Remember, if you're multiplying or dividing by a negative, this symbol flips around. Absolute value of y plus 5 is bigger than +18. Okay? Now you break this apart into 2 pieces. When you have a greater than situation, it means y plus 5 can itself be bigger than 18, or y plus 5 can be smaller than -18. All right, if it's smaller than -18, like -20, absolute value will make it +20, and it still makes this true. All right, so you solve both of them, get a solution. We got subtract 5 from both sides, y is bigger than 13, or subtract 5 from both sides, y is less than -23. All right, looks like this. 13, -23. 0 is closer to 13. I'm allowed to be bigger than, but not equal to 13. Or I'm allowed to be smaller than, but not equal to -23. Okay? As long as I'm outside of that range, I'll make this true.